I'm C.A. Bosberg with Electron Machine. I'm going to talk today about the use of our isolation valve adapter with a new safeguard tool that we've come up with. Here is an actual working isolation valve adapter. We have it configured with a window on one side so we can have our camera looking in there to see the inner workings, the spud. On the other side we have a water source hooked up under about 50 psi pressure just to simulate what the actual feelings would be in a real situation with process pressure. We would close the hand wheel down, and as you can see with our other view, the cup is coming down and going to seal on the spud inside of there. A small amount of the liquid will be trapped inside of that cup and spud between the sensor under pressure. So we'll need to relieve that pressure and verify that we got a good seal before we remove the sensor. I like to close it a few times, kind of rock the hand wheel, make sure we got a good seal, make sure there's no films or anything inside of there. We'll use our safeguard tool. Everything is tethered together so that we don't lose the pieces. Simply slides down onto the spud piece there in front of the threads. The orientation is not critical, it just needs to be seated on there. The retaining plate goes over the sensing head and it is secured with the pins. We've got our handle wheel closed. The first step, or the next step, would be to loosen the sensing head nut less than one turn to relieve the pressure inside of there and verify that we have a good seal without removing it from the threads completely. So less than one turn is the magic number, and you can immediately feel if the pressure has come off the sensing head or not. As I loosen it, and now we can proceed with the removal of the sensing head. The whole time making sure that we have no pressure on there. Once it's completely removed, it's still restrained by our safeguard tool, and we can verify that we have no leaks there, just a small amount of liquid that was trapped inside of the cup and spud. So then the safeguard tool can be removed. Along with the sensing head. Simulate that we do not have a good seal on this isolation valve. We're going to ignore the telltale signs of the pressure not being relieved from the sensing head, and we're going to continue to remove the nut even though you'll see it's going to be under a lot of pressure. So this is a situation that we hope would never occur. With proper training, this should never be an issue, but we want to show that this tool works and how it works to prevent a worst case scenario, even if all of that is. So the sensing head's installed, the isolation valve is simulated that it doesn't have a good seal. And the first thing, obviously, we have our safeguard tool in place. We're going to remove the nut, and we can see immediately with less than one turn that we have a problem. Obviously the pressure is not being relieved, the liquid's still flowing, you can feel pressure on the sensing head, you can't move it. But we're going to continue. Again, something that we never want to see in real life. We physically cannot move the sensing head. You can feel the process pressure on there. The nut is very hard to turn. Luckily we just have water here, so this is as safe as we can make this simulation. There it goes. So at least we've contained the sensing head. We obviously have a major problem, but we've contained the amount of liquid that's coming out here. We don't have an open 2-inch hole. We still have the sensing head retained in here, and obviously we'd have to figure out our plan of action. Talk about how strong it is. The sensing head itself has a little bit more, or a little bit less than 2 square inches of surface area on the end of the sensor. So when there's 150 psi process pressure in the pipeline, the most amount of force on the end of the sensing head is a little bit less than 300 pounds. So that's what this safeguard tool would theoretically the maximum force it would see in the worst case scenario. We want to show that it's over-engineered and it can handle more weight than that. So we've got a contraption rigged up here with 1,200 pounds on it now. Our safeguard tool is installed like it normally would be. The sensing head is loose from the isolation valve adapter, and we're going to suspend this load to show that we've got a more than 4 times safety factor from the safeguard tool. So as you can see, the entire 1,200 pounds is now suspended from the safeguard tool.